Hi everyone, welcome back to my channel. I'm Abhishek Paudil. Today I'm going to discuss about the open channel flow, and basically we deal with the gradually varied flow and rapidly varied flow topic, and we understand how to draw the water surface profile for a different kind of composite channel. And I also guide you which kind of which book you need to follow for the better concept of open channel flow in hydraulics. Here you can see in my interface I brought a very nice book, and this is a book written by K. Subramanya, and this is basically a open channel flow book. I have taken the fourth edition book, and you can get this book in market also in a hard copy. But here we discuss about the book, how is it, how it look like, and what kind of question have already been asked in IE examination. So let's discuss about that one. And basically I'm here just to guide you today. Let's walk through the book. Okay, so here the book basically it is open channel flow book, and here many questions have already been asked in IE final examination. You can see here. So I'm going to show you this is the book. This question I have already made the video of this question. This baffle block question, I have already made the video of this question, which is a sharp twisted wear, and in this case you need to apply the energy equation as well as the momentum equation. And in this question 1.29, you have to apply the momentum principle just to determine the force exerted on the baffle block, on the block. So this is also the important question here. So these are unasked question in examination, so it's very important for the final exam. So let's walk through the book, where you can see many questions over here. So in the energy and momentum principle, you can see these questions gives you the idea how to calculate the critical depth for different channel section. So this is also important here, and in this case I must have to tell you that this question, this is a water flows in rectangular channel section, and hump produces a drop of 15 centimeter water surface elevation. This kind of question has been asked in examination. So this one 2.11 also very important. So, and I must say that there is one question which is just just only the width constriction case here, and I have also made the video of that question where the width constriction only is occurring here. So width is constricted for 2.5 meter and 2.75 meter. So this is a very important question for the final examination. So many questions have already been asked, but I must tell you that this question here, a discharge of 16 meter cube per second with a depth of 2 meter flows in a rectangular channel. This question has already been asked in IE final examination. So keep strict with this book. I'm going to show you many questions here, around 20 to 30 questions here in the examples, unsolved example here, starting from the you can say starting from question number 34. Starting from question number 34. So you go to question number at last towards 46. Solve all these questions before going to the examination. Because these questions, I have just 2.44 as just asked in the examination. So many these questions are very normal questions here. If you if you do the numerical in the class, you can easily solve the questions. But you need the concept of hump case and with constriction and combined case as well. So I have shown you the the very important zone of this chapter, how the question can be asked from this book. There are many questions here, around 10 to 15 questions are very important for the final exam. So take it take it seriously. So let's go down here in the uniform flow chapter. So in the uniform flow chapter, you also stick with the the relationship between Manning's and Chezy and Darcy constant, and the theories to determine the economic economical condition of different channel section. That is also important for the final examination. And what are the what is the convenience, what are the section factor, what are the hydraulic exponent. These are the terminologies which can be asked in the final exam. So there is some unique question here, the comparison between this semicircular channel and rectangular channel. This is also important question which is unasked in examination. So a new question, unique question will be asked all the time, always. Here you can see the comparison between the rectangular channel section, triangular channel section. This is also important for the final exam. You just take it seriously and study this question which I have just told you. And let's go down here. You can see the sewer pipeline here, and it is expecting the discharge from you, and in section in the question number A, and it again expect you the depth of the flow when the discharge is 2 meter cube per second. It's a very important question, very important new question for the final exam. So next question. So go through this question for the final exam 3.14. So this question has already been asked in you can look at the question bank. You go to the question bank, you will see this question which has already been asked in IA final examination. So this is the condition analyzing the maximum discharge and maximum velocity condition. You using this concept, you have to do the numerical, and here the comparison is done here, and you can go through this question also. I recommend you to do this numerical from R.K. Rajput. Here you can see the condition of maximum discharge and maximum velocity. So using that condition and getting the discharge. Okay, so that's also a very important one for the final exam. And I must say that the getting the Manning's roughness N and for the different different composite section, and getting the Manning's roughness N, and at last use the Manning's equation to determine the discharge passing through the composite section. For that you need the composite area and you need the composite perimeter, and after that you get the hydraulic radius. And if you get the hydraulic radius, apply the Manning's equation. Q is equal to 1 by V is equal to 1 by N, R to power 2 by 3, S naught to power 1 by 2, and you get the discharge. That is also very important one. I'm telling you this question, and I must take you to the unsolved examples where you can see that question in which you have to get the Manning's N, and then later on you can calculate the discharge over here. You look at this question. In this question, the question is getting the dealing differently Q1, Q2, Q3, and using the different Manning's roughness and getting the getting the discharge. You can do by this way also, but you can you can convert these Manning's N different roughness value to a single one by using the Houghton and Einstein equation. So I suggest you to do it like that. So I'm going to take you to the numerical, and that one later on. Another type of numerical in which you have to find out the critical depth for different channel section. That is also important one. The critical depth for rectangular, critical depth for circular, critical depth for triangular, trapezoidal, and just a trapezium, and critical depth for the circular channel also. So you will have to use the Straub equation to get the critical depth for the circular channel. Keep in mind, understand, and go through the textbook. You will get that is Straub equation. Okay, let's get into the unsolved part of this one. Okay, I have already told you that this is a symmetrical, unsymmetrical. This is a compound channel section in which you can see different roughness coefficient over here, and you use the Houghton-Einstein formula to get the Manningsian, and later on you can get the discharge by calculating the cross sectional area and the weighted perimeter. Okay, so it's very important one, 3.8, very important question from this uniform flow chapter. These are the general questions. In the normal questions here, this is also the important one here. The triangular channel section 90 degree and rectangular channel section same material having same dead slope. I have already told you that the comparison between the rectangular channel section and the triangular channel section, and the comparison between the rectangular trapezoidal. These are the most basic concept question. How much power will be saved while discharging from a rectangular pipeline, and in discharging it by using the trapezoidal channel. Okay, sorry, I need to say the channel. So, and you also can find out the boundary shear stress by using gamma r S naught formula over here. So understand, so you need to calculate the ideal radius r, and you must have the S naught bottom slope. Okay, so this is also important one, 3.25 here. So this is also important. You can go through this question. So these are the questions which can be asked, because in IIE final examination the question will not be repeated. So be cautious and be meticulously study the go through the numericals, and try to filter it out for the final examination. So that will be less burden for you if you filter that out. This is a very important question here, 3.48. You can see here our trapezoidal channel has side slope 1, horizontal 1, vertical. Comparison of the economical condition of a lined channel and unlined channel. Even though it has already asked in IIE examination, but I must say that this is an important question, and a conceptual question can be asked again. So this one is important here. You can here in examination, final exam. There was 3 times the cost per meter square, but in this case here 9 times. So somewhere the cost may vary, depends upon the location, depends upon the area of the area where you are just comparing. So this one is 3.49 is also important, already been asked in examination. So so this one getting the discharge by using the depth, and getting the depth by using the discharge, simple concept. You need to check the discharge at the bottom part, and then later on you can just say that the discharge lies within the bottom part, or discharge will go up. So you have to check that one. I have done that numerical in the class, so to make it do this again. So this kind of question, you need to find out the normal depth by using the discharge. So very nice book. I must say that this is a very nice book for open channel flow, very conceptual. You can buy this book and you can use the hard copy. So I recommend you to do that, because if you have a hard copy, you can study all the time. No need to give stress to the eye. Okay, so that's why I recommend you to buy this one. It's a very nice book. You will get this book in National Book Center. I think otherwise you have to book it already, and you can call and the person of National Book Center, and you can verify whether the book is over there or not. So I recommend you to buy this one, because this is useful for further study also. So starting from the beginning, you can get the concept of the water surface profile and how to draw the water surface profile. Here the slope of the water surface profile is given here, S naught minus SF divided 1 minus alpha q square by T by Ga cube. So using this slope, you can say that the curve is backwater, or the curve is drawdown. You can say that the curve is horizontal or vertical. So this is how you can identify the profiles also by using the equation. But if you if you learn the practical profile, how to draw the practical profile, that is also okay to understand, because the practical profile are the profile which are drawn in the field. So that's why you can just directly relate the theoretical profile first understand first learn to draw the theoretical profile, and then relate the theoretical profile to the practical flow profiles, so that you will understand the understanding will be very easy, and you can relate everything, if it comes like a composite channel section. Okay, so these are the profile here. This is the theoretical profile. Here you can see the M1 profile is backwater, the M2 profile is drawdown, it lies in the zone 2, and the M3 profile is again the backwater, it lies in the zone 3. You can draw a single figure for the M1, M2 and M3 profile here. So I have taught you how to draw these profiles in the class. Okay, so first you must have the basic understanding of these theoretical flow profiles, and these theoretical profiles are drawn by using the concept of that slope, dy by dx. We have just derived the dynamic equation of GVF. So this is how the curve will be, it is a backwater or drawdown. So you must get that concept, and otherwise if you can draw the practical profile, that is also okay, I must say. So in this case here there is an steep slope profile. S1 profile is a backwater, S2 profile is a drawdown, drawdown the concave upward. This is also a backwater. S3 profile lies in the zone 3. So these are the profiles, and these are the critical slope profile, is very rare in nature. So horizontal slope profile, there is a normal drift, there is no normal drift line, because the yn is going to be infinity, because the S0 is 0. So that's why there is only two zones over here. So only the S2 profile drawdown and S3 profile backwater is over here. So these are the profiles. So you must study first, and you need you need to understand the practical flow profile over here. There is a practical flow profile just behind the dam. There is a M1 profile. It is normally flowing normally flowing at the NDL, but if there is an obstruction occurs, it goes up, and it goes down from the crest. Okay, so that's why this is how you need to learn. You need to draw the M1 profile. It is very parallel to asymptotic to the NDL, and then it's going to be horizontally over here. So this is how we draw the profiles, and these are the practical flow profile. You need to learn many practical flow profile, along with there are sluice gate. There are many hydraulic structures like sluice gate and dams and spillways, and breaking grades, and the grade is changing somewhere, and the profile will change. You must have to understand whether the profile occurs downstream of the control section or the upstream of the control section. So you will understand very nicely if you study thoroughly this book, or you go through my note also. You can get the concept very nicely. So this is a case of mild slope drop. There is a drop, M2 profile is occurring. This one is the M3 profile sluice gate. This question has already asked in IAE final exam, and just you can see the whole question the numerical from this profile. So you must understand every profile, almost 13 total profiles, and 3 theoretical profiles, M profile, S profile, and S profile. And after that you must have a knowledge to draw the composite profile. So I'll walk through in next video. We'll solve some problem related to this composite flow profile. So I'm just guiding you how to study here. Here in this case, the jump is occurring, and then curve is occurring. The curve is just one curve over here, because this is a steep slope profile. So and this is a sudden drop in my steep slope channel. There is a here entrance towards the drop, and this one is a sluice gate, and followed by a steep slope. So in this case, there is a steeper slope and a steep slope, then steeper to steep, and this will happen. So this is the break-in grade, you say. So in this case, the horizontal grade, and then first S3 profile and jump occurs, and then S2 profile, jump occurs. If it has to cross the CDL, the jump will occur. So I have already told you in the class. So these are the profile here. This is a profile where the jump is occurring here, the horizontal bed. There is a S2 profile, and there is a S1 profile here, and there is a S3 profile over here, just before the control section. That means just before the sluice gate and just after the sluice gate. So there is a reservoir, and there is a S2 profile over here. And I have already dealt with the pull elevation case, and which is going to be dominant. If the pull elevation is higher, the pull elevation is dominant, and if the critical depth is higher, then critical depth is going to be dominant. So you have to go from the normal depth to critical depth. In that case, okay, that question is also very important one. And in the break-in grade, mild to milder, steep to steeper, milder mild, these are the profiles here. And this is the most important profile over here, is steep to mild, where you need to check just the downstream of the control section, jump occurs downstream of the control section, or the jump occurs upstream of the control section. Both are not happening at the same time. So these are the two different cases, and you have to check, and you have to understand whether the jump occurs downstream CS or upstream of CS. So here are the mild to steep, these are the profile here. In horizontal to steep, you are gonna get the S2. In horizontal, there is only one profile, drawdown profile, that is S2, S2, and S2. So you can just relate that one to theoretical flow profile also to get the accurate drawing of the profiles. This is also the important question which can be asked in examination, final examination, where the slope is different, the grade is different, changing. And if the grade changes, you need to have the knowledge whether the curve occurs downstream or upstream, or both parts of the control section. Here is the curve is the mild to steep, so that's a M2 S2 curve has been drawn here. And this is the profile. It can be asked in a final exam, which is just a composite profile here, the composite mild to steeper mild and milder mild. Okay, so this is how to draw this kind of profile. I'll talk about these profiles, how to draw this composite profile in my next video, particularly dealing with the single question, single profile. Okay, this one is very important one for the final exam. Note it down. This is a example number 4.6. It's the very important one for the final exam. This is a composite one. You need to learn this. So another one is another one is in the unsolved examination example. Here you can see M2 profile, S2 profile, and S3 profile. You have to go through this one also. Mild to steeper, steeper to steep. You can go through this one. You just combine. You just learn to combine, how to combine this water surface profile. Here you can see if the sluice gate is over here and CDL is governing, CDL is above the NDL, then the jump occurs first and the curve is going to be S1 curve. You need to learn from the practical flow profiles. Okay, so this is the zone where the examination in final exam, the question will come from this one, steep to horizontal and horizontal to mild slope. This is how the question comes in the exam. Here the source is this one. So if you learn these all the profiles here and you get the answer at last, at last the answer is given here. This is 4.13. The answer is given. So you learn to understand by using above solved example, and look at my next video to understand that one, how to link up the different profiles, different slopes. So this very important one, 4.13. Note it down. And I'm going to take you to another one. 4.17 is an unasked question in the examination. So this one is also very important. And 4.18, there is a grade change. There is a change in slope, and even also there is a sluice gate here. So you need to draw how to draw, and I'm going to make the video how to draw this profile and the solved one first, and then later on we discuss about the unsolved one also. Keep in touch with my video. Okay, I've just dealt with that very important book, very nice book for the open channel flow, gradual varied flow and rapidly varied flow. So I suggest you to use this book and study this book meticulously to understand the basic concept of the this GVF and RVF in open channel flow. I must say, there are questions from mobile boundary channel also. Mobile boundary channel has just omitted from the new course, but for the old course, you must study the mobile boundary channel also. So you will see the questions from mobile boundary channel also here in the nice book. Here you can see everything about open channel flow. Okay, so I'm going to take you to another one, the rapidly varied flow, the important numerical, this one. So go through this one. In an overflow spillway, in this question you need to know the concept of fluid mechanics, the discharge passing through the way. You can see here, you can use the formula here, and you can use the energy equation to determine the required depth of the flow just downstream of the spillway. So this one is a very important question here. Here the elevation is also given here. This is how you can get the the elevation can be given here, but the height is already given. If the elevation is given, you subtract the elevation to get the height. You know how to do this. Okay. I need to tell you that this is how, when the mild slope here, the curve is m3 curve and jump occurs, and if the drop is over here, then m2 curve and it goes to the pool. If the pool elevation is higher than the CDL, take the pool elevation depth, and if from the channel bottom, if the critical depth is higher, take the critical depth. Okay, which is going to be dominant, you have to take that one. This numerical is also important one. You can go through this numerical also. This is also important one. You can suggest if there is a drop occurring, if there is a drop is occurring here, the depth will increases. You can apply the energy equation between the transition here to get the required parameters. Okay, you also take care about the question. You go to my my YouTube video, and in the YouTube video I have drawn a question which is from a sluice gate, which is from a sluice gate, and the sluice after the sluice gate there is a block, and you are supposed to get the force acting on the baffle block. Okay, that question I have done in my YouTube channel. Go to look at the previous video, and you get the concept, how to apply the momentum principle to determine the force exerted by flowing water on the block. So that there is only very recently asked in the final examination. So that kind of question can also be asked. It's a very important one. So go through my YouTube video for that concept. Okay, now I have worked through the book in detail. I suggest you to use this book for the examination, and many of you have already known about this book. And okay, I'll come in the next video. I'll take some numericals regarding the flow profiles, the composite flow profiles. So keep in touch with my video. Thank you so much. Okay, see you in the next video.